his valuable time on a very short notice to be to be chief guest of this uh, AICT ATAL Academy program, Green Technologies and Sustainable Engineering. It is organized by Department of Civil Engineering of our Rajasthan Technical University Kota. And I also welcome and congratulate our coordinator, Dr. Praveen Kumar, for organizing this event. I also welcome our Honorable Vice Chancellor, Professor R.A. Gupta Sahab, in this event as a guest of honor. He's a very dynamic and enthusiastic person, and I am happy to share that under his leadership, we are organizing number of webinars, number of faculty development programs, hackathons, and so many other activities in his guidance when he joined this institute almost 1.5 years back. Earlier to joining RTU, he was in MNIT as a professor, and right now he is guiding course of RTU Kota, or rather I would like to say it is the technical education of our state Rajasthan. So thank you very much, sir, for motivating all of faculty members and joining this program as guest of honor. I am thankful to Professor Sitharam. We met in AICT Executive Council meeting where we regularly meet once in a month in Delhi, and later sir was chairman and I was member of a committee which of AICT of ATAL Academy, which is being constructed at Jaipur, Guwahati, and so many other places. So I met sir in Guwahati also and so many other places. So I am very much thankful to him for joining us. Thank you, sir.
Thank
and for your information, sir, this program is also sponsored by AICT in ATAL FDP. So we are again meeting in the name of AICT ATAL program. It's not physically, but this time on online mode. So it is also another advantage that we could invite you on this online platform. Otherwise, it would be very difficult for you to travel from Guwahati to Kota because we do not have any air service in Kota. So it is advantage, we can say, of Corona that we are joining online, and I could see you after a long time.
Yes.
Thank you very much, sir. In this program, our coordinator has invited number of galaxy of resource person and speakers. I would like to also welcome all of them. One is Prof Sandeep Chaudhary from IIT Indore, Dr. S.B. Hegde from Udaipur Cement Works, KVL Subramaniam from IIT Hyderabad, KSR Narayan from Reliance Industries, Sanjay Pant is head civil engineering in BIS, I.K. Pateria is from NRIDA, that is PMGSY. Our civil engineering department is also linked with PMGSY activities. So I welcome all our resource person. I also welcome our faculty members of civil engineering department, our participants, and dear students. Sir, as you know that our institute, Rajasthan Technical University, is the pioneer in state in the field of technical education, and almost maximum of the engineering colleges, MBA colleges, MCA colleges are affiliated to Rajasthan Technical University. Our university was established in 2006. However, our college is very old, probably in 81 or 82. Our engineering college was established, which was later converted to University College of Engineering after existence of Rajasthan Technical University, and now we are having autonomy in academics field. Now we are in university departments. Right now, sir, for the information of our chief guest and speakers, resource person, that in our institute we are having BTech degree courses in 11 branches, which include petroleum, petrochemical, and aeronautical, and all conventional branches, civil, mechanical, electrical, electronics, computer, and IT. And besides BTech, we are having 12 MTech programs. We are having one MBA program also, and we are guiding PhD students also. In civil engineering department, sir, we are having 3 MTech courses. One in geotechnical engineering, another is in environmental engineering, and third one is in structural engineering. And we are also guiding PhD students in civil department also. In our institute, sir, we have very nice and learned, educated faculty, and most of them are PhD from IITs and other prestigious institutes. And Sir, with the help of AICT, we are organizing probably this is third or fourth, ATAL FDP program of our institute. We have received a number of other programs sanctioned from AICT. The major one is that our institute, electrical engineering department, has been recognized as QIP center for PhD in electrical engineering. So this our major achievement of our institute this year. Another is we are having AICT has provided an AICT doctoral fellowship for 8 or 10 students for PhD. They will provide the scholarship and other facilities to them. And sir, for your information, our NBA institute has granted NBA accreditation to our electrical engineering department last year. So we are progressing day by day under the leadership of our Vice Chancellor, sir. And sir, we have two TechU programs. One is for our institute and one is for the affiliating technical university. And under both the TechU programs, sir, we have purchased 5 to 6 crore of equipments, recent advanced equipments. We have organized a number of hundreds of webinars and almost 5 to 10 Smart India hackathon in our affiliating institutes. In our institute, we have organized around 50 webinars during this lockdown period by all our departments. So this is a great achievement for us that in during the period of COVID also, all our faculty members worked hard and organized number of webinars. So this is the major achievement, and as I know that our chief guest has to go for another meeting. So I once again welcome our chief guest, our vice chancellor, and all expert resource persons and faculty members. Thank you, sir, for joining us.
Thank you, Mathu sir. I take permission to present a brief about the program. This online program is on the thrust area, green technologies and sustainable engineering, with specific contents on construction materials from industrial waste for sustainability. As already narrated, distinguished experts from academia and industry will share their rich knowledge and experience with the participants. I am glad to share that participants from 19 states. Sir, from your state, Assam also, we have 2 participants from CIT Kokrajhar. So we have participants from Andhra Pradesh, Arunachal Pradesh, Assam, Bihar, Delhi, Gujarat, Haryana, Jammu Kashmir, Karnataka 8 institutes, Kerala, Madhya Pradesh, Maharashtra, Odisha, Rajasthan, of course, Tamil Nadu, Telangana, Uttar Pradesh, Uttarakhand, and West Bengal. So I am glad to share this information. The industries covered includes coal-based thermal power plant, steel producers, zinc producers and processing industries, and stone processing units. Rajasthan is very rich in stone processing units, but we have a lot of waste products from this area also. I remember situation in our country in 90s, particularly in Kota when I joined here. In 90s, we used to produce more than 3,000 ton fly ash in our city. At that time, hardly 200-300 tons was used. And by 2005, the situation changed drastically and the technologies were adopted by the industry. And now the situation is that almost 5,000 or 4,500 ton fly ash is produced, and there is a long queue for takers. Similarly, this has become possible only due to research and adoption by the industry. So many stalwarts involved in this, particularly in the development of standards, like Shri Sanjay Pantji, who has been involved in the beginning in the Bureau of Indian Standards, will share his experiences. KRS Narayanan sir, who is from Reliance, has been involved in large projects and particularly the codal specifications development of plastic waste in road construction. Then Dr. Pateria is involved in the implementation of the fly ash in road construction. So researchers as well as implementing agencies are brought together in this program. And similarly, our Dr. Trilok Gupta from CTI Maharana Pratap University will talk about stone processing waste in cement and concrete and the durability of concrete using these materials. So, Chittor region of Rajasthan is known for zinc industries. So Dr. Bhavna Tripathi shall be talking about this. Similarly, it is important that if we mix these byproducts in our particularly construction materials, how to ensure the quality assurance of those end products. So Dr. Hegde shall be talking about the online and offline tests being conducted in the cement plants when we use slag or when we use fly ash. So JSW Cements has been the pioneer in the production of, say, development of technologies of slag in fine aggregate and slag in cements, etc. So their vice president and zonal head West shall be sharing their experiences and their implementation in the afternoon today. So with these words, I invite our Honorable Vice Chancellor, sir, to grace us. Professor Adi Gupta, sir.
Yeah, good morning, Professor Praveen Agrawal Saab. The program is ATAL, and you are also ATAL. You are working very hard. So in RTU, we look always you as a ATAL person. Very hardly you are, and you are implementing everything very nicely. This program is very relevant, green technology and sustainability engineering. It is really topic is very relevant, looking to present scenario, and Professor TG Sitharam and then Sandeep Chaudhary, my very good friend. He was earlier at IIT Jaipur in structural engineering, and then so many experts you have invited. Engineer Mahmood Ahmed, and then NK Sawant, and then Professor Hegde, and so many experts from wonderful institutes. One of professor from basically Professor Civil Engineering IIT Hyderabad, then from GVP Bhagat Singh from University Chennai SRM. There, Professor Sancheti is as a vice chancellor, is also a good friend of mine. So looking to this, and you know, these experts, the participants from all the corner of country. It's a wonderful program. So this program, such a program can be conducted by the learned professors of RTU. So Sanil Mathur is also very hardworking. So I'm really very happy, and I really welcome, especially Professor TG Sitharam Sahab. He spare little time for us in his busy schedule, and other experts. And sir, nowadays, just I want to finish in 2 minutes that the RTU is really dedicatedly doing a lot of work, and we mean basically business. We really dedicated for the technical education in Rajasthan, and the professors and faculty members of Rajasthan Technical University, they understand their responsibility, and accordingly they day and night they are doing hard work, and we in this pandemic situation even we are doing everything very basically meticulously and precisely we are doing, and we know, we understand what we have to do, what is our responsibility, and we are doing accordingly. So I am sure this program, basically this ATAL, this program we are conducting, green technology and sustainability engineering, everyone will be benefited out of this this basically program. And I want to give a message to the participants, because we have different type of participants. So such type of the platform hardly we basically, it is, we are very lucky that so many professors are there. So everybody should take advantage of such type of the programs. And those who want to pursue their PhD or MTech, they should basically, they can collect so many topics from this type of the programs. So I am sure that the outcome of this type of the program will be wonderful. And I congratulate the organizers, and I welcome all the participants, especially that such type of the program is being conducted for them. So, and I'm really thankful that you invited me, and so that I could meet at least Professor Sitharam and other experts, and I could recall I stayed there, um, your IIT Guwahati once, and I enjoyed there. So thank you very much, and I'm sure the participants will get advantage of this. Now, thank you very much. Over to Praveen Agarwal.
We request our esteemed chief guest, Director IIT Guwahati, Dr. T.G. Sitharaman, sir, to bless with his words. Kindly, sir.
Namaste. Thank you very much. Professor R.A. Gupta, Honorable Vice Chancellor of RTU, Kota, Professor Anil K. Mathur, the Dean, Faculty Affairs, Professor Praveen Agarwal, the course organizer, and all the distinguished resource persons. I see many from IIT as well as industry, and then participants. Amazing to see from 19 states, all participants, and the faculty of Rajasthan Technical University, Kota, and all the students and volunteers who are assembled on this webinar platform on green technology and sustainability engineering. I'm very happy, first of all, to be here. As Professor Mathur and myself, we have sitting together and discussed many times. And also he happened to visit IIT Guwahati once.
Thank you. Thank you.
Yeah. So when he requested, I immediately said, definitely I will be there. Okay. It becomes easier today. You see, it's much easier. See, we have advanced by at least 10 years, because of this pandemic. Otherwise, the resistance to online would have been there, and we would have taken at least 5 years to come to this stage. But this pandemic has pushed us. It's a lot of savings. So this platform and this kind of interaction are going to be sustainable. And also the green technology and sustainability engineering, which is part of AICTE ATAL program. It's a very apt program. At the right time you have chosen. Why I said right time, 2-3 issues. Green technology and sustainability engineering is first of all a multidisciplinary topic, which you have invited multidisciplinary experts from civil, mechanical, everywhere, okay, and industry also. So as per as all of you know that National Education Policy 2020 has been adopted by the Government of India, and Ministry of Education has already been renamed as a first step, actually talks about this kind of a multidisciplinary programs. And the areas covered are construction material, coal-based industry, steel-based industries, zinc industries, stone processing. Dr. Agarwal talked about stone processing is very high in Rajasthan. I want to tell you also, you are also a pioneer in zinc industries. Okay, you are the one who gave how to really process the zinc from. So it is the Rajasthan is the key state where majority of the zinc processing industries are located. And I also am happy to share and say, I keep visiting Rajasthan, whether it is REA mines, Rampur Agucha mines, or whether it is Zariba mines or Zawar mines. All those mining industries I have come maybe about 30 to 40 times, because I'm a consultant to them from last 20-25 years, to Vedanta, Hindustan Zinc, okay, for all those companies. So I'm happy again to address all of you here. And Kota is a very unique thing for IITians. because most of your products only we get. Majority of the people who are studied and learned in Kota end up in IITs. So
Right.
this is a fantastic connection, So between this program and me being there and all of you having me there. So let me come straight to the topic, green technology and sustainability engineering. I would like to start with a quote: go green or face extinction. Go green or face extinction. So to counteract the effects of the climate change and pollution, we need to definitely go green. And this green technology, please note that green technology is also known as sustainable technology. So Dr. Agarwal, you should take a note of it. Green technology and sustainability engineering, even though it's a catchy word, but green technology, also known as sustainable technology, takes into account the long and short-term impact on the environment. The green products basically are environmental friendly products, energy efficient products. Maybe they can also end up due to recycling, and also the products which addresses the health and safety concerns. Products come out of renewable resources, and more all go in the making of green product or technology. All of these actually a part of green technology. So another important thing about this particular webinar is the faculty development program. So it's a very, very aptly chosen. Why? Because this is a very key issue if you want to improve the quality of the technical education in the country. Okay, so this faculty development program is very, very important, and all of these people should be made aware of sustainability. See, that is another thing. See, I don't know how many of you know, all the countries in the world signed an MOU or Memorandum of Understanding in the United Nations to implement the Sustainable Development Goals. There are 17 such goals. This was signed in 2015 and it came into effect 2016. India is also a signatory of this. This Sustainable Development Goals is for 15 years to alleviate poverty. And many, 17 goals are there. One of them is alleviate poverty. Another is water, clean water, and all the issues. There are 17 goals, and these goals have to be fulfilled by every country, or they have taken a commitment that they will do it so by 2030. Friends, 2030 is not very far away. It's only 10 more years left for us to implement the Sustainable Development Goals. So if you knew before, 2000 to 2015, Millennium Development Goals were implemented by the United Nations for 15 years. They saw such a fantastic, growth in all the countries, and also the poverty alleviation program. They took a oath that the Sustainable Development Goals will be implemented. 17 goals with many, many action plans. I think every state is working towards that. So by 2030, these sustainable goals have to be fulfilled, which is a great challenge for us. And this pandemic basically has shown us, even though it's a very difficult time for all the students, and particularly I think Kota has suffered a lot because there is no coaching classes this time. For most of the IIT entrants, they all studied themselves, and JEE Advanced was done very late. But I'm very glad to tell you all that process we have completed, and the JEE Advanced also is completed, and the students are admitted. The classes are going on. We all, adopted to the new order. There is a new order because of the pandemic, and that new order is accepted by everyone. And I can see that today in this webinar as well. See, all of you are there, all resource persons are able to come, and all this is possible, I think, because of COVID-19. Otherwise, we would have tried to get each other to go Kota in 3 days, to reach Kota and go back. So I'm very happy that large number of participants are attending this event, and majority of them are engineering college teachers and also diploma college teachers, and also very important thing is research scholars are also attending. If India aspires to become a $5 trillion economy, as our Honorable Prime Minister has put forth before us, to reach this mark, we need to evolve a system and mechanism to convert the present demographic dividend into high quality technical human resource, capable of doing cutting edge research and innovation and deep tech entrepreneurship. This is very critical. This is very good. That is, research and innovation and deep tech entrepreneurship is very critical. Promoting innovation through R&D, research and development, should help to develop new products and services that drive growth, create jobs, and improve the national welfare. Research and development is the backbone of a globally competitive, knowledge-driven economy. Investing in research and development ensures high market participation. Market participation refers to the ability of the researcher to engage with its customer base and hook their interest by offering unique products relevant to societal need. This is where this course will be very useful. Unique products. This unique product should be the green products, green technology, and sustainability engineering, which is a very multidisciplinary. I congratulate the team to come up with a fantastic topic, as well as the areas like construction material, steel, zinc, stone processing, fly ash. Fly ash, I would like to say, I also worked in fly ash a little bit. So, and I was very happy to hear Dr. Agarwal highlighting on fly ash. There are a large number of, fly ash industries, thermal-based power stations, which produce a lot of fly ash. Even though there is a greater awareness, thanks to TIFAC and all the programs of the Government of India, there is a greater awareness to reuse the fly ash in many materials, both civil engineering and also road making, everywhere. And as he rightly said, there are long queue for takers of fly ash in many states. But there are some states, still there is excess and going to the ash ponds. Because myself, designing ash pond in Orissa, because they do not have any cement plants nearby, so they cannot supply this fly ash to cement plants. Thanks to National Highways, has come forward. So there is still a lot of work needs to be happening in fly ash as well. So I hope this workshop will give a lot of input to all these students. And I also see at the end, Dr. Agarwal has put up a session on stress management by a psychiatrist, which is a fantastic, during the pandemic time. Let me congratulate him, because it's for thought-provoking program, which involves these things. So more than psychiatrist, I advise you, Dr. Agarwal, please get a yoga expert and ask him to do a small exercises of yoga and maybe about 5 minutes of meditation online, which will definitely help everybody. With these few words, I thank again the organizers for giving me this opportunity to be here with you. I really enjoyed being here, meeting your Vice Chancellor, Professor Arya Gupta, and Anil is again a good friend of me, and we keep meeting again and again. So with these few words, I wish the program a great success, and I'm happy to be part of this inaugural function of the Green Technology and Sustainability Engineering. I wish all the participants the great success in whatever they would like to do. But from this course, you carry good memories, particularly on the multidisciplinary aspect of sustainability engineering. Thank you very much. Namaskar.
Thank you very much, sir.
Thank you, sir. It is my privilege to express deep gratitude to Professor Dr. D.G. Sitharam, sir, the Director, IIT Guwahati, to spare time to grace this session on a very short notice. Honorable Vice Chancellor, Professor Arya Gupta sir, has been very encouraging to us to organize such events. I am grateful to you, sir, and our whole team is grateful to you. Professor Anil Mathur himself, a prominent professor in the theme of the FDP itself, always supports our endeavors. We are grateful to you, sir. Experts and resource persons, as Director sir has rightly said, that from industries as well as academia, IITs, like Professor Sandeep Chaudhary ji, Professor KVL Subramaniam sir, and others, very distinguished persons, KRS Narayanan sir, to whom request was made, everyone obliged despite their busy schedule. Their rich experience in research and practices will benefit us, all of us. And I am grateful to all the participants who chose us out of several programs on the AICTE ATAL portal. And I assure you, sir, Director sir, with your kind words and advice, we will definitely involve one yoga session also for us people. And we look forward to great association with you and these participants, sir. Mathu sir, please.
Thank you, sir. डायरेक्टर प्रोफेसर सीतारामन जी का बहुत बहुत धन्यवाद सर इस कार्यक्रम में पधारने के लिए। हमारे सभी रिसोर्स पर्सन, सभी पार्टिसिपेंट्स, वाइस चांसलर से सबका धन्यवाद। जैसा कि मैंने बताया, प्रोफेसर सीताराम जी को एक दूसरी मीटिंग में जाना है, सो हम इस प्रोग्राम को यही एंड करें प्रवीण जी।
हाँ सर,
थैंक यू, नमस्कार।
थैंक यू सर, थैंक यू सर फॉर योर जॉइनिंग। थैंक यू सर, थैंक यू।
मैं प्रोफेसर संदीप चौधरी जी का स्वागत करता हूं एंड वाइस चांसलर सर की इजाजत हो तो हम इनका सेशन चालू करें।
या डेफिनेटली सेशन बिल्कुल चालू करिए आप। और प्रोफेसर संदीप चौधरी जो है वो बहुत ही लर्नड प्रोफेसर हैं और ही इज वेरी बेसिकली वंडरफुल पर्सन। वी वर्क टुगेदर एट MNIT and he basically having a lot of qualities, very calm person but with the system. And because I'm looking here today and I'm really feeling very happy that it is a wonderful time me to hear Sandeep Chaudhary. So yeah, I welcome him, invite Professor Praveen to Sandeep, continue.
Thank you, sir. Actually, you're telling your friend, but I think more than friend, you are a mentor to me, and I still carry many good feelings with you, and like I try to implement those what I have learned from you, and it was wonderful to work with you. I think RTU is fortunate to have a leader like you. That is all I can say. Because really it was wonderful. Like we spent a lot of good time and a lot of qualities, like when you are dean faculty and the way one should be compensated and that simplicity, and that is really wonderful. So I am also feeling very happy to see.
Thank you, Sandeep, and thank you very much. So now continue करें आप अपना talk kindly.
जब तक प्रोफेसर चौधरी साहब अपना स्क्रीन शेयर करते हैं, मैं पार्टिसिपेंट्स के बेनिफिट के लिए उनका स्मॉल इंट्रोडक्शन शेयर करना चाहूंगा। प्रोफेसर संदीप चौधरी has been, as rightly said by our Honorable Vice Chancellor, had been with MNIT Jaipur for about 2 decades. Then he switched to IIT Indore, and he is the person who built civil engineering department at IIT Indore. I am very grateful that he has been working in this theme, and I requested him to give a theme lecture today, and he has kindly consented. Over to you, Professor Sandeep Chaudhary, sir. चौधरी सर, आपकी आवाज नहीं आ रही है।
संदीप जी, आपका माइक अनम्यूट कर लें।
Yeah, I think now I am audible.
Yes, sir. Yes, sir.
Yes.
Yes, and the screen is also visible, I think.
Yes,
Right,
sir.
right.
So thanks to Professor Agrawal, thanks to Professor Mathur, and many thanks to R. Gupta sir. And of course, I think it's not the first meeting for all of us. We have met number of times. including Professor Mathur also. And anyway, I have spent a very good time with Professor R. A. Gupta. So now for next 1 hour, I will be bothering you a little bit about this theme, that is the construction materials from industrial waste for sustainability. We'll try to look this from a different perspective, because people have been talking about different types of construction materials for sustainability, and we have seen over the years that people from different disciplines, they have been approaching in this area, that like not only people from civil engineering, but people from chemistry side also, people from chemical engineering also, people from physics also, they have been now working in this area, and everybody is trying to see how different construction material can be used for the sustainability. But somewhere we are lacking in a holistic picture. Whenever we go for a new material, most of the time we tend to just go for the certain tests like compressive strength test, flexural test, some durability tests, and that's all. And then we somehow try as a researcher, as an industrialist, somehow we try to force that idea upon the industry, or we try to force that idea on the people that this waste can be used in the construction. But now I think it's the time to look holistically. We have to identify the areas from different perspective. We have to see which material can be used at which location for which application, what is the optimum dose. And it's not only about just talking about advantages, what are the pitfalls, because we should be quite aware, and we know that it's not a one-day thing that today we get some strength. Nowadays we have to talk about durability also. So you have to look what will happen after 10 years or 20 years. So somehow we have to look into a complete picture. So we'll be picking up one by one different types of materials and the ideas and the issues which are there. So one thing is, first is we'll be discussing about the need of incorporating waste for development of sustainable construction materials. Then we'll be discussing about this classification, that we can use these materials as supplementary cementitious material. We can use them as aggregate also. We can use them as reinforcing material also. We can use them as architectural material also. Now we have to look for the potential of waste also, because each waste has a different potential, and we cannot put all the waste at the same level. Like there was a discussion going on about the fly ash. And of course, in fly ash, we have reached up to a certain level where we can say with authority, and even Indian standards have put those clauses where they have allowed. So we'll come down to those Indian standards also. Then potential of waste as aggregate, potential of waste as reinforcing material or as architectural material. There might be certain waste like fly ash, which can be used as a replacement of fine aggregate also, which can be used as replacement of cement also. And there are other also like ceramic waste that can be used as a replacement of fine aggregate, as well as that can be used as supplementary cementitious material. So what is the optimum use and what is the best use, best possible use? We should look into that. Before going into that, we do know that Indian Standard 383 now, they have allowed the uses of most of the waste materials in the construction, particularly in the concrete. Because though people were using different types of waste in concrete, but there was no documentation as such, and there were no guidelines. But in 2016, Indian standards came forward. Of course, Mr. Pant will also be delivering a lecture. I do understand that. So he'll be discussing a little bit about that. But after that, IS 1383, the revision of IS 1383 in 2016, there has been a shift. People have now been started thinking very seriously about these aspects. If we talk about the need of incorporating waste, the idea is one side we have to consume the waste, so that's a headache for us, and other side we have to use natural resources for concrete, and we know that the concrete is most widely used construction material, and the basic ingredients of concrete are cement and fine aggregate and coarse aggregate. And everywhere we do need the use of natural sources. So there's a pressure on one side to reduce the natural sources, but at the other side, there's a pressure to consume these wastes also. So somehow we can make a balance, and if we use the waste in concrete, that's a win-win situation, and that is what is the need of our. So if we use the waste, we know mostly we can consume waste material, we can resolve disposal issues, we can use them as alternative to conventional materials, and mostly they need no or very less treatment, and they provide a twofold solution. Now we'll go one by one and we'll discuss different types of materials which people have been using or which people have been talking about. So one is like materials can be used as supplement to cementitious material, they can be used as aggregate, they can be used as reinforcing material, and they can be used as architectural material. Now coming down to supplement to cementitious material, we can use fly ash, we can use GGBS, that is ground granulated blast furnace slag, we can use rice husk ash, we can use silica fume, metakaolin, glass powder, marble powder. Of course, like fly ash, I do understand that Dr. Agrawal has worked extensively on that. And of course, Kota is Kota has a lot of fly ash, and RTU has been working on forefront in this area of utilization of fly ash in concrete in different manners. But we'll be discussing a little bit about that also. So these are different materials which can be used as cement or as a replacement of cement or as supplementary cementitious material. We do know that some of them can be used as a replacement of fine aggregate, but as engineer, we know that it's always advisable to go for better uses. That is, if you use them as replacement of cement, that is a better situation. So coming down to this fly ash, like we know that there are two types of fly ash basically. One is class F, which contains less than 7% lime, glassy silica and alumina. And then there's another class C, which contains more than 20% lime, which is self-cementing. We know nowadays, mostly if you go to the market, you'll just find Pozzolana Portland cement, because the reason is this fly ash is being used in the cement manufacturing, and instead of OPC, we're just getting Portland Pozzolana cement. So fly ash is an important ingredient there. And as Professor Sitharam was saying, it can be used in embankment, soil stabilization, flowable fill, asphalt, concrete. Geopolymers, of course, nowadays, that's another type of concrete where there's a complete replacement of cement by the fly ash. We can use it in roller compacted concrete, bricks, etc., fly ash bricks, etc. But the idea is, what is the optimum uses, and what are the advantages and what are the disadvantages? So if we see the microstructure of coal-based fly ash, mostly we can see that it's a sort of a spherical shape, and it gives a sort of later strength. If we need a high early age strength, we'll not get that strength. So we should be knowing that it gives the strength, same strength, but at a later age. And it is so much used now, it's difficult to find out ordinary Portland cement in the industry. Because I see that there are some persons from cement industry also. So for research purpose, like also if we have to use Portland this OPC cement, we have to ask especially for procurement. Otherwise, mostly PPC is available. This fly ash can be used in soil stabilization also, and nowadays like fly ash bricks are also being used, and there are mandatory guidelines also from NGT also and from the government also that within certain range of these thermal power plants, we cannot use fired clay bricks. We have to go for fly ash bricks only. Another supplementary cementitious material is like GGBS, and it is obtained by quenching molten iron slag from a blast furnace. And here, of course, we know that if we talk about the cement, mostly what is important is CaO and SiO2. So here it has both the components, CaO and SiO2. So it can be a very good supplementary cementitious material. And if there's a higher CaO content, it will raise the slag basicity, and thus it will increase the compressive strength. The benefits are it reduces the risk of damages which will caused by alkali silica reaction. That's a durability aspect. You might have gone through that in your bachelor's or master's. And it gives a high resistance to chloride ingress, of course, and provides high resistance to attacks by sulfate and other chemicals. And there's just a schematic picture which is showing that how it is obtained from the steel furnace slag. And you can see the microstructure. If we compare it with the microstructure of that fly ash, the particles there were mostly spherical particles. But here, if you see this microstructure, these images, of course, are scanning electron microscope images. And these images are showing that the shape here is not a spherical shape. It's a sort of granular or plate shape. And of course, we should understand that the spherical, if the particles are spherical in nature, they have their own advantages. And if the particles are plate in shape, they have their own advantages. So accordingly, we can see like the areas of the applications can be identified where GGBS can be used or where fly ash can be used. Another very interesting supplementary cementitious material is rice husk ash, and it's the agriculture byproduct which is obtained by burning husk under controlled or uncontrolled temperature below 800 degrees centigrade. It is highly pozzolanic because of 85 to 90% amorphous silica, and pozzolana activity. Just to repeat, we call a material pozzolanic material when in presence of water it will give us cementitious properties. So it's a highly pozzolanic and it has 85 to 90% amorphous silica. Important point here is what has been written here is amorphous silica. So just presence of silica does not matter. It should be amorphous in nature. So there might be some other material also which might have a higher silica. But if it's crystalline in nature, then it's not going to give us any advantage. So what is important is we should look for that amorphous silica. And of course, it has 5% alumina also. And it has a large surface area. And of course, that will result in sort of higher reactions. And this forms from the microporous structure of ash particles. It has a wide application such as pillar, additive, etc. So when we are using it as a supplementary cementitious material, we should understand that it's no more a free waste. Nowadays, if you have to procure this rice husk ash, we have to procure it in form of bags and we have to pay for that also. So it's just not that you are using a waste. Now we have to look for an economy also because it has some other advantages also. So people have been using that in industry for other purposes. So now there is a cost associated with that. So we have to see the benefit vis-a-vis the amount of money which we are spending. The benefits are it will reduce the risk of damage caused by alkali silica reaction, high resistance to chloride ingress, and of course, high resistance to attacks by sulfate and other chemicals. If you see its microstructure, again, if it is in unground form, we will see that there is a plate or granular type of structure, but in ground form, there are very small particles. Another interesting supplementary cementitious material, and if you talk about that supplementary cementitious material which gives us maximum strength, so that stands among the top supplementary cementitious material, silica fume. So it's an ultrafine powder which is collected as a byproduct of silicon and ferrosilicon alloy production. It has spherical particles which are less than 1 micrometer in diameter. So which is approximately 100 times smaller than average cement particle. Now this small size is USP of silica fume because then it gives you a very high surface area and which leads to good amount of reactions. So this high fineness and presence of silica oxide between 85 to 95%, 98% is responsible for high pozzolanic reactivity. And oxides of silica fume, they react with and consume calcium hydroxide, that is CH, which we obtain from hydration of cement. So it leads to densification of matrix, strength improvement, decreases porosity, better resistance to chemical attack. And we know that whenever we have to go for high strength concrete, that is concrete above M50 or M60, mostly that's a compulsion to use silica fume because the type of supplementary cementitious material which are available readily in the market, silica fume stands at number 1 in the sense that it gives us maximum strength. Of course, the cost is associated with that, along with because of those reactions, the heat of hydration, etc. Those issues are associated also with that. But anyway, to have a very high strength concrete, you have to necessarily go for silica fume. And you can see here the particles are so much spherical in nature, so small and so spherical. So that gives it all advantages. So the idea is if we are going to use any material, whether as supplementary cementitious material or as a replacement of fine aggregate or as a replacement of coarse aggregate, we have to link it from the microstructure. And here we are, of course, just seeing the scanning electron microscope images. I have not touched upon the XRD and SPDS part. But ideally, if we are going to use some materials as a sort of supplementary cementitious material or whatever form we are going to use it in concrete, we should start from this scanning electron microscopy. We should go for the XRD images. We should go for the TG, etc. So first we have to see the individual characteristics of that material. We should not go with that when that it's a waste, and if there's any waste, just put it in concrete. But once if we know this SEM images, once we know this XRD, we can very well judge what's going to happen finally when we are going to use it in concrete. And of course, then we can go for these mechanical tests and then durability tests. And the best way is to perform all the tests from the microstructure to the final test or to the final application in the structural elements like beams, etc. And then we have to see in totality that whether whatever are our assumptions from this SEM images or whatever we are perceiving from SEM images or whatever we are perceiving from XRD investigations, whether that is getting reflected in the final results or not. And if that is not getting reflected in the final results, what is the problem and why the difference is coming? Like from silica fume, it is expected that the particles are very small, they are spherical in nature, they have high amount of silica. So mostly it should give very high strength, but sometimes it might not be giving very high strength. And what is the reason behind that? That we can see only if we see everything totality from microstructure to complete analysis. Another very recent area in which people have been working is that LC3 cement or use of this metakaolin. Now this is produced by calcination of high purity kieranite clay at a temperature range of 700 to 850 degrees centigrade. And it's finer than cement particles. So this helps to fill the micropores of binder. It contains high amount of reactive silica and alumina. It provides better particle packing. Benefit is it improves the compressive strength at early stages, low permeability, and decreases chloride ion penetration. Of course, still it's a material which is a new material, and people have been working at different aspects, like on the uses of fly ash and on the uses of silica fume. There's a complete literature available. Like you can find out the effect of fly ash on the compressive strength, flexural strength, tensile strength, on all the durability properties, on the microstructure. Same is about silica fume. And in this fly ash, you can find out the effect on ductility properties, impact resistance, fatigue resistance, etc., temperature resistance. But in metakaolin, etc., people have worked on certain aspects, but still there are many areas where people need to work upon. Like one of the areas in which we are working right now in IIT is that its effect at high temperatures. We are trying to see if we use metakaolin, what is the behavior of concrete at very high temperature, that is 800 degree, 1000 degree, or 1200 degree. So this is like a sort of microstructure of metakaolin. Another supplementary cementitious material is glass powder. Again, here the increase in fineness increases the pozzolanic properties, and we know that in glass there's a high amount of silica, and mostly if we are getting silica, Ca, both are contributing to this pozzolanic reaction. And there's a less water absorption and a smooth surface. And of course, here the issue is the alkali silica reaction occurs among the silica of glass and alkali in the cement. So if we are using the glass powder, then we have to go with a sort of caution, and we cannot go like in the case of fly ash and in case of silica fume, we can go for very high levels of replacement. But here the level of replacement is of course limited by this aspect alkali silica reaction. So that's another interesting research area, that can we control this alkali silica reaction, and can we go for high level of replacement of glass powder in concrete. So that's another area. Of course, there are benefits involved here. It improves workability, mechanical properties, decreases permeability, etc. And of course, another important material like which people have been using particularly in Rajasthan is marble powder. It's a inert or quasi-inert material, and of course it has been used as a fine aggregate, but people are like trying to see its uses as a supplementary cementitious material. And what happens is that calcite and Portland cement paste lead to calcium carboaluminate formation, and this calcareous pillar has an important binding properties that is developed by hydration of calcite and C3A. So there is a strength improvement at low replacement levels, which is observed mainly due to filler effect. But high replacement level are causing delay in setting time and lowering the strength. Of course, this is another interesting area, that how to go for high replacement levels of marble powder in concrete, because there is a huge amount of marble powder in concrete, which is there in Rajasthan, and still there is no solution for that. People have worked at different aspects, but whatever aspects they have worked upon, that does not go for a high volume replacement. So if you are using such type of waste in concrete, then we have to look for a high volume replacement, and we should try somehow to see that how we can overcome these adverse effects. Can we use some admixture? Can we use some other waste material, or can we use some other material which is not waste to counter these adverse effects? So all of us know that there are huge amounts of marble stone dust, and this microstructure we can see. Again, it's not a spherical in particle, it's sort of granular, or you can say plate type of structures is there. Now, if we talk about the waste as aggregate, then we can use scrap tire rubber particles, we can use waste plastic aggregate, we can use C&D waste, copper slag, and again marble Kota slurry, and we can use cenospheres. Scrap tire rubber particles, of course, Dr. Trilok Gupta will be talking, I think, a little bit about this also. We work together on this aspect. So basically, what is important for this scrap tire rubber particles is that it has whatever you work on this, and its application is a global application, in the sense that the other material which we have discussed, sort of in supplementary cementitious material, marble powder, or some other type of materials, and in fact in waste as aggregates also, if we talk about some other material, they might have some local applications, but this is one of the waste which is a global problem across the world, and people are still struggling to find out a solution for this. So scrap tire rubber particles, they can be classified in three categories: chipped, crumb, and ground rubber. And of course, we should try to first see that how people are disposing of the waste rubber tires. So mostly they are just throwing it on the ground, or what they are doing is sometimes there's a pyrolysis technique, or they are burning these rubber tires, and by burning the rubber tires, they get sort of black carbon, and that they are using as a pigment, etc. And the other thing is they are using steel fibers, whatever they get, as for some other purposes in the industry. So now when we try to use these waste rubber tires in concrete, we have to see vis-a-vis its other applications in the industry. Just using the waste rubber tire and just using these chipped, crumb, and ground rubber in concrete and without any advantage will not serve a purpose. So what we try to do is we try to carry out comprehensive experiments here in this case. So we used particularly these rubber fibers, and we went through this microstructure, and then we went through this sort of all fresh state properties, mechanical properties, durability properties, ductility properties, thermal properties, etc. And then overall it was found that if we use these waste tire rubber particles in the concrete, the biggest advantage is that you get a high ductility. Now, this is interesting that though there might be a bit of loss in the strength, but you are getting a highly ductile concrete. So, or an impact or energy absorbing concrete. Now, in concrete, we should understand that there are many places, in fact, more than 50% construction of the concrete, the strength is not an important parameter. We do have an inhibition that if we are going for the concrete, it should always be a high strength concrete. But many places, a minimum grade of concrete works fine for us. It should only be durable. If you're using in pavements, etc., then we don't need a very high strength concrete. What we need is, instead of the strength, we need there a high abrasion resistance, a good energy absorption capacity, etc. So if my waste rubber tire or these rubber fibers are giving me a highly ductile concrete and they are giving me good abrasion resistance, why not to use? Why should not I use them in these pavements or paver blocks, etc.? So this is like one of the applications. We can use them in the machine foundations also. People have been now using this in India in crash barriers also. The roadside crash barriers, mostly they are metallic sections. Sometimes people use concrete section, but if you use these rubber fibers in those concrete sections, they will have a certain ductility and they will have energy absorption capacity. So if there's a crash or there's accident of vehicles, so then those crash barriers, they can absorb more energy. So this is also like a huge amount of scrap tires available all over the world. And these are different types of rubber aggregates. We can use them in ground form, we can use them in crumb form, we can use them in chipped rubber form or aggregates. Similarly, we can use waste plastic aggregates, also waste plastic bag, PET bottles, PVC pipes, high density polythene, thermosetting plastics, mixed plastic waste. Different types of waste can be, plastic waste can be used in concrete. Of course, but it's always with a caution that what happens is when we are using the waste plastic, that will form a sort of impermeable layer. So if you talk about the microstructure of the concrete, there is an impermeable layer in the microstructure, or that will create a problem in the bonding of this CSH gel and the aggregates, etc. So the strength is naturally going to decrease. So we can just not say that we are going to use plastic in the concrete and we are going to make a great concrete. That's for sure that the strength is going to decrease. But again, only strength is not a parameter. There are so many other parameters. So we have to look for those applications where strength is not important, but the other parameters are important. And in those cases, like paver blocks, etc., we can use these waste plastics. Like this is also again a work done in collaboration with Dr. Vivek, Dr. Trilok, where we are seeing waste plastic aggregate concrete and we shredded waste plastic bags. We used it in concrete. Of course, the strength reduced a lot, but the other durability properties improved. And finally, we could see that we can use it in paver blocks. Of course, a patent has also been filed in this regard. Another interesting aspect is CND waste, and now this CND waste is widely used. And of course, like nowadays I'm working in Indore, so here of course, municipal corporation, they have made it mandatory to transfer all the CND waste to their plant, and their entire CND waste is being recycled, and they are using it for making building products also, and it's happening all over the world also. Of course, here we can use the CND waste in different forms. It's not only about, we can use it as a coarse aggregate also, we can use it as a fine aggregate also. There are certain issues anyway related with the CND waste. One is that it reduces the workability to a large extent, because the cement particles which are stick to this CND waste, actually that absorbs a lot of water. So that reduces the workability to a large extent. And then we have to use more water, so that changes the water cement ratio. Or at times we have to go for admixtures, but there's a limit on admixture also. And of course, this is a problem associated with most of the waste material, that whenever we are using some waste material in the concrete, it has a direct effect on the workability, and that's always a problem to get back the same workability. A little bit of the workability can be achieved by the admixtures, but there's a limit on that. So, but anyway, people have tried to work on different aspects here. So different treatments can be done for these coarse aggregates, recycled coarse aggregate. 3-4 treatments are now widely established treatments. And if you treat the coarse aggregates, recycled coarse aggregate by that manner, then you can successfully use them in the buildings, etc. We can use them as fine aggregate also. So of course, people have worked a lot about this coarse aggregate application. But now people have started thinking about this fine aggregate application also to give a complete solution. And many countries now, they have made complete buildings also by using this CND waste. And another important problem associated with CND waste is like the segregation of the waste. because on paper it seems simple that if a building is demolished, there's a C&D waste and we can directly use that C&D waste in our concrete or in our construction activity. But there are a lot of other waste also involved. That is, there's a waste of glass, and there are other timber waste or many other types of sanitary ware waste. So many other type of waste are also involved. So that's also another important area about this segregation of the waste. Of course, in many countries, it's mandatory to provide only whenever you are dumping the waste, then you have to dump the waste only after the segregation. So there are many companies which work on that. But that's an interesting area. And also more interesting is it's not only just about the uses of just those recycled aggregates, etc., but to use these other type of waste also, like tiles, floor tiles, sanitary ware, etc., and ceramic also. And people have been working on this utilization of ceramic waste in concrete, and they have found that it gives a very good strength and very good durability. And it has certain pozzolanic activity also, this ceramic waste. And of course, it has a high thermal resistance also, because the reason is simple, because when these ceramics are made, they're already made or they're already baked at a very high temperature. So we do expect that the temperature, high temperatures will not have a negative effect on this C&D waste. So that is also important area. We can use these recycled timbers, etc., also for different purposes. So we have different types of waste, like recycled coarse aggregate, brick masonry waste, ceramic waste, concrete waste, timber waste. So idea is to use each type of waste for its own specific purpose. Another is a copper slag, and we know in Rajasthan there is a big mine in Khetri where there's a lot of copper slag which is available. So this can also be used as aggregate, and it contains SiO2 plus Al2O3 plus Fe2O3 is more than 70% of the total consumption. And it has shown certain pozzolanic properties also. And people have seen that its use as fine aggregate increases compressive and tensile strength of concrete, decrease in water absorption and depth of carbon penetration. And we know this is also important aspect, depth of carbon penetration, because the corrosion is not directly taking place as such. That's related to the carbon penetration. So somehow, because it reduces the pH near the reinforcement. So it's not that finally we have to look for the corrosion. We have to first look for this carbon penetration. And we know that we call this as a carbonation, and the simplest of the tests is phenolphthalein test, where we spray the phenolphthalein and we see the change in the color, and we can find out the carbonation depth, etc. So it's very important to reduce the carbonation depth, where this copper slag helps us. And it's again a microstructure. So again, the particles are not spherical particles, but sort of plate-like particles. Cyanospheres are also nowadays being used as aggregate. They are produced as a byproduct of coal combustion at thermal power plants, and hollow microspheres of size 5 to 500 micrometer, having shell thickness of 5 to 10% of the diameter. They contain 50 to 65% amorphous SiO2. Again, we are stressing upon amorphous word because we are just concerned with the amorphous silica. 20 to 30% Al2O3 and then some Fe2O3. And it's lightweight, inert, hollow sphere. So it has high resistance to thermal and electric conductivity, superior acoustic properties, and it can be used for developing lightweight cement composites. So we can make ultra lightweight cement-based composites with a density in the range of 1120 to 1920 kg per meter cube. So that is it. You can see the microstructure. So very spherical particles, and so that is its own advantage. We can use the waste as a reinforcing material also, like we can use scrap tire rubber fibers, recycled steel fibers, waste plastic fibers, and natural fibers. And there is again, there's a big misconception here. People think that when we are using these fibers in the concrete, that will increase the flexural strength of the concrete as such. But it's not about the increase in the flexural strength directly. There might be a bit of increase in the flexural strength. But instead of flexural strength, what is important is these fibers, whenever we use whether waste fiber or a fiber which is not a waste, whenever using the fibers, instead of achieving a high flexural strength, what we are looking is we are looking for arresting the cracks in the concrete so that it doesn't have adverse effect on the durability. Many times, many scholars, they have a misconception that if I use the fibers in the concrete, then I should get a very high flexural strength. But it doesn't happen most of the times. And some of the quite popular fibers which are available in the market, industrial fibers, if you use them in concrete, you will not find any increase in the flexural strength. So that should be very clear. It's not about the increase in the flexural strength. And when we are using the word reinforcing here, it's not about the reinforcement at the structural level. It is about the reinforcement at the material level, where we are trying to arrest the cracks to ensure a proper durability of the concrete. So these, like we can use scrap tire rubber fibers for means as a reinforcing material. Again, of course, here we are getting increase in flexural strength, but use of fiber does not necessarily mean that we have to, that we'll get an increase in the flexural strength. Of course, what is important here is we get a high impact resistance, and anyway high resistance to abrasion, chloride ion and carbon penetration, etc. So this is like the microstructure of scrap tire rubber fiber. Now if we go like more detail in the microstructure, you will see there are certain cracks here at the microstructure of the rubber fiber. So what happens is like when there's a loading or flexural loading on the concrete, so first this rubber fiber is going to fail, so it will absorb the energy, and we know that if a material is going to fail, it will fail only after absorbing the energy. So that energy absorption is taken up by this rubber fiber, and that is the advantage. So we have to look for that level. So this crack at the rubber fiber here at this microstructure, that's telling a lot about the final structural behavior of a concrete element or a concrete beam which is carrying these rubber fibers. Because what we can see here from the microstructure, there are cracks. And why those cracks are developed? Those cracks are developed when there was a load on the concrete. And if the cracks are developed in the rubber fiber, that means the energy was taken by the concrete, by the rubber fiber. So that means the energy absorption capacity of the concrete is going to increase. So this is how we have to relate the things. It's not just about using some waste material and just finding out some properties. We can use recycled steel fibers also, again from the scrap tire, because they're 60% rubber, 20% steel fibers, and 20% textile fibers. Again, but the issue is it is not that simple, because what happens is like when we burn the rubber tires, we get the steel wires from after burning the rubber tires. But those steel wires, they are so much intermingled among themselves that it's very hard to cut those steel wires in small sizes so that they can be readily used in concrete. So again, that is an area where people have been working. Of course, for research purpose, people are cutting those steel wires and then they're using it in concrete, and they're getting some advantages or some improvements in different properties of the concrete. But that is not sufficient until we get a complete holistic solution. The idea is still that if we are using these steel fibers at a mass level in concrete, then how to go for that mass level application? What is the way out to cut down these steel fibers at the mass level? So this is also another important area where we need to look into. So these are like recycled steel fibers, and this is the microstructure. So you can see the problem is they are so much coagulated sort of problem is here. And so how to segregate these steel fibers so that they are evenly distributed in the concrete. And if we burn the steel tire, or if we try to take out these steel wires from the rubber tires, what is the way out to get them in a proper manner so that they are not in form of a bunch? We can use waste plastic fibers also from the waste plastic bag, polythene, or PET bottles. So people have used PET bottles directly as a reinforcing bars to structural members. Of course, at a very small scale, it cannot be in the big structures, but people have made some small structures by directly using the complete PET bottle as a reinforcing bar, because it's lightweight, high strength ratio, and durable. It increases the flexural strength if you're using a complete PET bottle as reinforcing bar. So we can use this like you can see here waste plastic fibers, and you can use waste PET bottle as reinforcement, complete bottle as reinforcement, etc. So this also has been done. You can use recycled glass, carbon fiber, reinforced polymer fibers also. They have high compressive tensile fracture and impact strength. And of course, we can use the virgin glass or carbon fibers also, but they are quite expensive. So a significant amount of unfinished material is left as waste along with a large amount of FRP discarded at end of service life. So that can be used, of course, if somebody is interested in working in this area. Or, what we should aim at, connecting with the industry, those industries which are producing the virgin fibers or virgin material, because there's always a certain amount of wastage which they are throwing out. So somehow if we can connect with those industries and the waste which they are throwing out, and we can use that waste for our purpose, that will give us an advantage, because the industry will be ready to give that waste material for free, otherwise they have to dispose of. And we'll get almost same properties, because industry might be using that material for some other purpose. But for our purpose, whether we are using the virgin fiber or we are using just some waste material, which is waste from some other perspective of the industry, then it is same. So we should look into that aspect also. So this is like how recycled GFRP fibers look like, or how recycled CFRP fibers look like. And just to have idea on the scale, their sizes have been shown. We can use natural fibers also, coir coconut fibers, and this increases mechanical performance similar to conventional fibers. They're lightweight, strong, high strength ratio, and they need no or very less treatment cost. And of course, they're economically feasible over synthetic fibers. But at the short term, we can have some good properties, but still it's an area to work upon. What's going to happen in long term after 10 years, 20 years, what's going to happen on the pre-shrinkage, carbonation, etc. Because of this, are the cracks going to develop or not? So these are another interesting areas, and what's going to happen at the microstructure level. But we can think of using such type of fibers in concrete. And of course, like here, just I'm showing like the way people have used, they used like bottles and bifusion bricks, recycled cardboard bales, foam glass, agriculture waste panels, denim insulation beds, etc. They're used for waterproofing products also, green slate, bioglass, etc. So like natural stone-like plates, Rocco sheets, wine cork tiles. So different types of materials, they can be used. I'll just open up one more. I hope this presentation is also visible. This other presentation.
Yes, sir. Visible, sir.
Yeah,
yes,
this
sir.
is about unfired bricks. So just to
yes,
infuse the confidence, like I'll just talk for another 15 minutes or so, because from 10:30 I have meeting. So just to infuse the confidence, like we try to now, because that is one aspect that when you talk about using some waste material at the level of the material, but ultimately it's just use in material is not important. Ultimately, what is important is what product we are getting, and can we sell that product in the market. It's not selling in terms of money, but is the industry ready to take the technologies, the industry ready to adopt the technology which we are telling them, or means society ready to accept the technology. So what we are going to offer to the society, because if I say I use waste rubber fiber, it improves the ductility, it improves the energy absorption capacity, it improves the carbonation resistance, etc. Society is not concerned with that, or the end user is not concerned with that. What is the product which you are offering to the end user? So we try to develop some sustainable building products. And here there's a case study of unfired bricks. Like we know that in unfired bricks, this I'm skipping that. I'm just coming to this sustainable building product. So why building products are important in sustainable design? Because we have to protect the nature, we have to minimize the resource consumption, we have to maximize resource reuse, and so on and so forth. And ideal sustainable building material, if you say it should be environment friendly, it should have no adverse impact on health of occupant, it should be reclaimed, recycled, it should be made from renewable raw material, and there should be a use of renewable energy in network activities. So if you see a very idealistic sustainable building material, then on the right hand side you're seeing a figure. It should involve all of these, so which gives you a life cycle of a building material. Of course, we do understand as an engineer, it's not always possible to go for all these or to have all these 6, 7 things in each of the material. But ultimately, we should know that if you're saying some building material is an ideally sustainable building material, then it should fulfill at least some of these parameters, if not all these 7, 8 parameters, at least 4 to 5 parameters. And if you talk about the life cycle analysis, then we have to look for the embodied energy, resource reuse, recycled content, etc. So we have to keep all these different aspects. It's not only about the single aspect which we have been using or which we had been discussing in our earlier presentation. Along with that, we need to look for embodied energy. What is resource reuse? What is the recycled content? How much it is recyclable? The material should have low ozone depletion potential. It should be natural, biodegradable. It should be locally available, rapidly renewable material. It should be compliant with clean air and water. So all these ideas, all these criteria should be kept in mind. So if we talk about the existing masonry products, normally we have either the fired bricks, but we know there are a lot of disadvantages which are associated with the fired bricks. So we're not going much into those details. There are many issues like medium to high energy intensive industry. There's a pollution, highly labor dependent, disposable issue. So the alternative was like we can go for unfired bricks, and we know nowadays a lot of people or a lot of construction activities, there's a use of unfired bricks or fly ash bricks. And these are typical fly ash bricks. But if we go further in the detail, that's not the end of the story. So we have just like sort of addressed a tip of the iceberg if we are using the fly ash bricks. What we need to do is we need to make it further more sustainable. And before that, we need to understand how they're manufactured. So like a typical manufacturing process is like there's a grinding of wet lime and then fly ash plus stone dust plus additional water and so on and so forth. So there's an entire process which is involved. It's not like a fired brick where just there's a mixing of clay and then you just fire that and limited processes are involved. So if you see, there are a whole lot of processes are involved. So if you see like from the point from where we started, it's not only about the uses of the fly ash, it's about the uses of the fly ash in the product. So here we are using it in the product in the brick. And it's also not only about the uses of fly ash in the brick only. Ultimately, it's efficient use. That how can we put some interventions, can we intervene in this manufacturing process? Can we make it more robust? Can we make it more sustainable? Only then we can say we have got a sustainable building product. So just not use of fly ash in the concrete, it's use of fly ash in the brick, one step ahead, and then efficient use and optimum use of fly ash in the brick, and then some modifications in the manufacturing process. So like here, what we try to do is what should be the quality of raw material, what should be the proportioning, and one of the areas where we are lacking till now, we have been talking a lot about these fly ash bricks, etc. But unfortunately, there is no Indian standard code which talks about the mix design when we are making a mix for the bricks, fly ash bricks. So that's a major challenge to the fly ash brick manufacturing industry. And many of the fly ash brick manufacturing industries have closed down due to this particular challenge. So that's a very big challenge. And like we have our Indian standard codes, IS 10282 for concrete mix design, etc. So why can't we have a code for mixed design of these fly ash bricks? The challenge is that if we have the fly ash from different industries, then each fly ash has different chemical composition. So what happens is like one day they're getting a fly ash from one industry, other day they're getting the fly ash from other industry. These brick manufacturing industries, there is a whole lot of difference in the chemical composition, and there's a lot of variation in their quality. So it's more or less the same challenge which we face in the concrete mix design. If we change the query for fine aggregate or the coarse aggregate, then we'll get a lot of difference in the ultimate strength or final strength. So same is happening with the fly ash manufacturing industry, fly ash brick manufacturing industry. But unfortunately, there are no guidelines. Even from the same industry, you'll get different fly ash with different chemical composition, with different at different point of time in a year. So how to accommodate that? How to account for that difference in the fly ash? And how to characterize that? Like when we are saying that we are using this fine aggregate in the concrete, then the fine aggregate should fall in zone 1, zone 2, and it should not fall in zone this, it should not fall in zone 4, etc. The coarse aggregate should have this grading, and there are certain whole lot of parameters that they should pass through all these parameters. Cement should pass all through these parameters. Only if all these fine aggregate, coarse aggregate, and cement, they're passing through all these parameters, only then we can use those aggregates or those ingredients in the concrete mix design. But unfortunately, there's no such parameter which has been established by Indian standards or by any of the government organizations for the use of fly ash or use of some other ash in fly ash brick manufacturing industry. So the important challenges which are related are technical feasibility assessment of local waste material. There's a high breakage cost due to low early age strength, because again, this manufacturing process also needs to be streamlined. There's a high working capital requirement due to long production cycle. And there's economical feasibility comparison is not available. Like if there's an industry, the industry wants to use one type of waste, there are 5 types of waste, which type of waste the industry should use. So there are again no guidelines associated with that. So again, that's another big challenge. And then what should be the optimization of manufacturing aspects? That what should be the mix proportion? What should be the mixing strategy? What should be the casting method? What should be the curing condition? And then performance assessment of waste incorporated brick mechanical durability aspects. And then there should be a public awareness, and we should try to give the technical support to manufacturers to increase acceptance of waste incorporated brick. Now the question is how to deal these challenges while maintaining the sustainability of unfired bricks. So there can be different strategies, like we can maximize the use of waste material as ingredients. We can select the stabilization technologies to incorporate maximum amount of waste. We can use local waste materials rather than transporting the waste from distant source. We can use efficient mixing strategies, that is mixing time, mixing sequence, mixing equipment. We can use efficient casting method, way of compaction, compacting equipment. We can use efficient curing techniques, medium curing. What should be the curing medium? What should be the curing parameter? What should be the curing age? And then there's we can prepare local maps of industrial and domestic waste for effective utilization. So different challenges are there, like waste. People have been using, just talking about fly ash, use of fly ash, but why can't we use rice husk ash? Why can't we use metakaolin? Why can't we use biobriquette ash? Why can't we use copper mine tailings? Why can't we use ceramic tiles? If you're using this, what is their effect on the manufacturing process of these fly ash bricks? Or what is their effect on overall physical properties, overall durability properties of the concrete? What is its effect on the weight? What is the effect on the costing, etc.? So all these aspects, and what is its effect on the production cycle, etc. So all these things need to be looked into much more detail, and that industry means, like there are certain guidelines for aggregates. What are those guidelines for the industry? There should be a ready chart, readily available chart. We cannot expect industry to carry out all the detailed characterizations, which most of the facilities, which also sometimes we also don't have the access to. So local manufacturing industry, we can't expect them. So we have to give them some ready solutions. We have to give them some solutions in form charts, in form of some graphs or some guidelines, so that they can If some industry is thinking about use of rice as cash, what are the guidelines? If industry is thinking about using copper mine tailings, what are the guidelines? What is the optimum use? What is the maximum? What is the minimum use? What are the adverse effects? What are the positive effects? So all these aspects need to look into. Like again, you can use recycled paper mill residue, phosphogypsum, pond ash, quarry dust, crumb rubber, brick dust waste. So like here, like we try to see cement clean dust, raw boiler ash, ground boiler ash, GGBS slag, and then we try to see what happens when we are using different type of ash. Interestingly, even in a city, you will find 20 types of ash from 20 different manufacturing industries. Like each manufacturing industry will produce a different type of ash. The chemical characterization will be completely different. The chemical composition will be completely different. So how to incorporate those changes? That's a big challenge. So I will stop right now here, though we have worked significantly in this aspect also, but I'll just stop here because what is important is not about, I can present those solutions also, but to have that in mind that if we really want the sustainability in the construction industry, it's not about just doing some basic tests and just saying this is useful or not useful. We have to put that to the product level, and at the end level, we have to tell that, okay, this is the product which we are offering, and these are the guidelines. And if there's change in these properties, you just make these changes and you can get similar product. So that can be our contribution to the construction industry for the sustainability, instead of just doing some 10-20 watt tests from the research perspective and telling that this improves, this decreases, this increases, and this will happen, this will not happen. But what is the end solution at the level of the product? That is more important. Any questions? I have, I think, 2-3 minutes.
Yes, participants may unmute themselves. Yes. Participants may ask the questions. One participant has asked whether the recording will be available. So I may inform you that AICTE has asked us to send the YouTube link, so that YouTube we shall be sharing on the RTU website also, RTU e-content channel also. Manoj Punia, you may unmute and ask the question if there any. You have raised hand. Mr. Manoj Punia, please.
Please tell me the function of silica fume in the concrete.
Mm-hmm. Yes.
Sir, good morning. I am repeating again my question. Sir,
the function of silica fume is it increases the strength. It increases the strength significantly. But at the same time, it's not really available and we have to pay for that. Along with that, there are certain other issues associated with that. High heat is liberated and all other aspects also.
Okay.
So it's not just very simple.
Thank you, sir. Thank you so much.
Professor Ari Gupta, sir, our Honorable Vice Chancellor, sir, stayed for the full session. So I am grateful to him. With your permission, sir, may I thank Professor Sandeep Chaudhary, sir, because he has to attend another meeting.
Yeah, I am quite very sorry. I would have loved to spend 1 hour more, but because of that NDMA meeting, I'm very sorry for that.
Yes, sir. So we are very grateful to Professor Chaudhary, sir, and you have rightly said it is not making a product or making some tests for the research, but to make it adaptable to the industry, to the end user. That is required for these materials, and that is what we experienced in the case of the fly ash bricks in Kota. In year 2000, brick manufacturing started, but user was apprehensive. But it slowly we were able to convince, and by 2008, 7-8 years it took, and now 300 industries are producing bricks. At that time, hardly 2-3 industries started producing bricks. So they are getting good market adaptability, and of course, we have seen they have stood the test of time as well. And previously, the artisans, masons were also apprehensive, and some changes, some modifications were made, and then the product become adaptive. Similar is the with other specialized materials, and rightly you have mentioned. So I, on behalf of Rajasthan Technical University, and I, on my personal behalf, grateful to Professor Sandeep Chaudhary sir for sparing his valuable time despite his very tight schedule. Thank you very much, Chaudhary sir.
Yeah, thank you. Yeah, thanks, Dr. Agrawal. Thanks, Professor Mathur, and many thanks to Arya Gupta sir.
Thank you, sir.
Sometime in Kota. Sure.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you.
There is an announcement for the participants. Many participants have asked about attendance. So please note that a feedback link has already been sent to you. Kindly fill that. That will be marking the attendance, as well as this Google Meet software shall mark the attendance. Our next session, we shall start at 11:15. We shall be starting technical lecture exactly at 11:30, but you are requested to join between 11:15 to 11:25 a.m. so that we may start right on the time. With your kind permission, sir, Honorable Vice Chancellor, sir, if permission is there, I may close this session here, sir. And I am very grateful that our esteemed guests and expert, Guru Vittal Saab from Central Road Research Institute have also joined. My friend from Nagpur, Dr. Pusatkar, has also joined. So I am very glad to have them here. Professor Pusatkar sir has also worked in the fly ash in roads. Many participants have given me feedback that they wish to have one more session, some more session on the fly ash in roads. So we will request CRI senior chief scientists as well as many experienced participants to share their experiences of research and practice. And with this, I close this session. We assemble here again at 11:15 a.m. Thank you, everybody. Meet you again at 11:15 a.m. Thank you all.